Okay. I thought my mic was off. Now you all can hear me. Sunai Dira, hello. Yeah. Okay, okay. Uh, okay. Okay, yes, yes. Everyone can hear us. As you can see, this is not a well laid out stream, but it gets the job done. And today's stream will be mostly in English. I have actually three guests. One of them is on the way, but I'll intro them in some time. I'll turn on your mics, okay, Rohan and Narayan. So Rohan is CEO of Bellatrix, and I think you all have known him so many videos. You all have seen Bellatrix's stuff on Career Scientist. Narayan, my community will know Narayan mostly from New Space India podcast. If you all don't know New Space India podcast, you all are missing out on a lot of rich information. Definitely check out. And yeah, do you all have anything to say, Rohan and Narayan?
Thank you for having us, GS.
Cheers. Yes.
Yeah, likewise, look forward to the stream.
Right. We are waiting for Astronil to join, and I'm waiting for ISRO's website to not be on load. For some reason, this has stopped working. Uh, does anyone know any additional anything else where this was uploaded? They they keep changing these layouts. Like this particular page, someday someday it is like just gallery, someday it is gallery videos. Now it is just gallery. Okay, I'll just ping Astronil again, and yeah. So so both of y'all have worked in sending stuff to space, right? So starting with Rohan, how is the experience here? Like integrating and like how do you transport it like in a car, like you wrap it in a suitcase and then you transport it? Like how does that process work?
Yeah, so if you look at any space hardware, care must be taken. It has to be assembled in a clean room and needs to be packaged perfectly and only to be opened at the integration area at Sriharikota. So in our case, we went by road because we had a pressurized cylinder inside with xenon, as a matter of fact. So, and this gas is very, dangerous if the temperature exceeds 50 degrees. So care must be taken, and you're not allowed to carry it by flight because of
Oh,
explosion hazards. So any pressure vessel, there's a lot of requirement from ISRO side to meet and qualify. And first you have to submit the paperwork. And once the review committee has thoroughly reviewed, then you are allowed to bring it to SHAR. But you're not supposed to open the package till you reach the launch pad. In our case, launch pad one from where the PSLV
hmm.
C-55 launch took place. So they call it the 42-meter building,
Right. Oh.
meaning the height of the tower is 42 meters, and you approach before the payload fairing is closed.
Mm-hmm.
That's where you go and assemble. So it was very interesting to see things up close.
That
Something which
uh, I often
something which
notice someone
cameras.
literally takes the satellite in your hand and then puts it on top. That is so scary looking, and they do that.
Yeah, but you have good trained people there who take extra precaution, and only limited people are allowed inside at that point of time. It's basically a clean room. So what they've done is it's a
Right.
makeshift clean room there. So it's very different from clean rooms which you're used to see. It doesn't look like what a fab facility has or something. It's just a thick curtain,
Mm-hmm.
and it's a makeshift clean room which they do.
Oh.
Yeah, and it's temperature and humidity controlled. But yeah, only trained people will be accessing it. Um, As far as PSLV is concerned, even the avionics module is in the fourth stage, right? Sits everything there.
Hmm.
So you have two different teams, the satellite team from URSC as well as people from VSSC working together, and you will hear the checkout people calling from VSSC, where they remotely, turn on and turn off certain
Oh,
instruments on board PSLV. Before they said it was all done at Sriharikota. Now it's all done remotely to increase your launch
hmm.
cadence.
How interesting. Narayan, uh, everyone knows you in my community for New Space India podcast, but you don't often talk about sat search. Do you want to tell everyone what is sat search, what you do?
Yeah, that's normally I don't really market ourselves so much. So, but basically, we are building like a mix of Google and Amazon for space, where engineers can find the entire supply chain. So the problem comes from having realized, as somebody who is from India and who worked in Europe, I often used to ask my colleagues in the German Space Agency while I was there,
Hmm.
tell me one supplier in India who you know who can help provide some components, and most people would say, I have no clue who is in India outside of ISRO.
Right.
So that really sparked this idea that we should make a platform like an Amazon for space, where everybody can be in one platform and we can really have buying and selling of components for satellites, rockets, all kinds of things in one place. So today we have, I don't know, maybe about 3,000 suppliers, and we have customers in about 35 countries that we work with. But yeah, our goal is to have about 100,000 suppliers. So if somebody is eventually building, I don't know, a Mars colony or something like that, we want to be the backbone of supply chain for all of that.
Okay. I often often when something new is developed in India, like in case of Bellatrix, that thruster Arca 200, I was frequently using sat search to compare the specs. It's a great component wiki. So I used to go check out others thrusters and compare the specs.
Yeah, I mean, the idea is, if you can build a future which is like Siri for space,
Hmm.
that would be very interesting, right? So basically, if you said that, tell me somebody who can provide, I don't know, a camera of this specification, this sensor, this imaging quality, and so on. And if the result appears to you automatically, then you save engineers many hours of work, right? So there's a lot of interesting things that you can do with such automating a lot of these kinds of queries, and it's one of the more complicated things that you can build. But this has been probably done in other industries, but space is still very far behind with all this.
Right. Yeah, very primitive.
Yeah, most people don't realize that probably the flight computer on Chandrayaan 3
Hmm.
is probably like, I don't know, at least a 10,000 times worse than what is on people's smartphones, right? Because
Oh,
nobody wants to take a risk to adopt new technology, which is not space proven in interplanetary flights.
right, right, right.
So when people say space is cutting edge,
Hmm.
it is also kind of like an anomaly that space is cutting edge in terms of having to have reliable things, but it's not cutting edge to try out new things so aggressively as people on the ground would try out. Like for example, Nvidia has a new GPU.
Hmm.
There's lots of people using it for all of these large language models and chat GPT and so many other things.
Right.
But imagine using the latest GPU that is coming out in space. That will happen probably 10 or 20 years from now.
Damn. So, but again, if you don't, I mean, there was this discussion happening on that Russian forum. I think Titanium had shared in the Discord how Luna 25 is still using like processing and techniques of that era, 10, 20 years ago or 30 years ago, whatever. But it still works. So what is the incentive for upgrading to a better computer if your old computer works?
That's always the dilemma that most of the designers will face, right? Because at the end, people want to add additional functionality, additional sensors, better resolution, so many other new things. But then the challenge is always in optimizing performance versus cost. So if ISRO had a budget of, I don't know, like a $1 billion instead of $100 million
Hmm.
for Chandrayaan 3, for example, maybe they could have tried many, many, many new things
Okay, right.
at the end. But if you constrain the budget, then people also then look at solutions that are very well established at price points that they are very well aware of. Because to go through the qualification cycle to adopt a latest GPU to be space qualified can take several years and cost several tens of millions of dollars. So,
Hmm.
and if you say that the timeline is, I want to do this mission in 2 years and I want to do it at a certain cost, it may not work out. So ultimately, anything can be tried to be adopted to space, but it becomes a question of how aggressively you want to pursue it and at what cost.
Right. So on that note only, Rohan, when you were planning with your flight computers, what was your thought?
GS, the point what we followed Bellatrix is it is not a success-based design. As yesterday there was an article where ISRO chairman said it's a failure-based design.
Right,
So
right.
the approach is completely different. For example, if you look at the OBC, it will be as simple as possible. The chip has to have some radiation tolerance inbuilt with error correcting code capability,
Hmm.
and it is supposed to do only minimal tasks. Okay, so that you can revive the satellite in case something happens. If you need more processing or anything, you have an additional card, which we call it as a payload card, which interfaces with the OBC. The OBC as
I want to
such
take all
will be bare bone or keep it as simple as possible, whereas your payload card can be as complex as possible. So that is the design approach we took, and so that performed very well. This particular approach.
Okay, and like this bidirectional code which you had discussed,
Mhm.
ability to update your software. This is
Sadly,
dictated
with
by.
with the poem that was not possible with the PSLV poem platform because it is RS-485 and it is kind of half duplex. So it can give you telecommand, but it's not possible for you to push code in that. So if there is any software corruption, right,
Hmm.
it is basically end of mission. So we have requested VSSC to at least enable RS-422, a bus
Hmm.
protocol, so that if there is any software error, you can actually upload a software from here. So, but as far as the computer itself is concerned, it's an inbuilt feature where you can push the code.
Okay, so that day Somnath in the interview had said that if there comes a chance where the rover is dead but
Mhm.
lander is alive and they have to do a hop, they may consider doing a hop, then they have
Correct.
to upload the new GNC algorithms.
Yes.
So
That is
Chandrayaan,
possible because
hmm,
ISRO uses a protocol known as 1553. A little different, but it's very rugged, robust, and the interface is easy. So this is basically a mill standard protocol pioneered by US.
oh,
So all ISRO missions use a 1553 protocol. If you look at commercial players, they'll all
hmm,
be using either I2C, simple I2C, CAN bus, spacewire, RS-422, something like that. But ISRO uses 1553. It's because mainly because of the redundancy aspects. So there you can upload codes, everything. But this is all for the satellite. The launch vehicle works little differently.
okay, okay. Narayan, how does like you have been with Indian space industry. I think you're one of the OG
Yeah, the
Indians.
OG.
Yeah, the OG Indian space entrepreneur. The number of companies that definitely have increased. The signal to noise ratio, what about that? How about the quality?
I mean, look, at the end of the day, there will be people who will come and go, and you should expect that if we have 1,000 companies, and even if 100 of them are successful, if they can make it big, then it's good enough, right? So I'm not so bothered about the quality of companies because the market will decide who will survive and who will not
Hmm,
at the end. So we should just allow people to do what they want to do, because at the end of the day, if you don't have real demand for your product in the market, obviously you cannot go on forever.
right. I've seen very
So I'm
niche
not worried.
companies.
Huh?
I've seen very niche companies like making decouplers. Is decoupler such a big market that that can be your only business?
Look, I mean, the thing is, every business does not need to be a big business. There are people also running small bakeries on the street,
Right.
right? Because they are very passionate about, I don't know, baking bread.
Correct.
So there may be somebody who says that I am very passionate about decouplers and I will only build them. And I'm happy to only do business with that particular component. And I don't mind having just a 5-person team
Hmm.
doing that for 20 years.
Right. So what is the most niche space business you have come across?
That's a tough one. I would say like one of the most niche space businesses that I've probably come across is probably like even building transportation boxes for satellites.
Oh,
So because that is an extremely um, niche area
huh.
at the end, because depending on the kind of satellite that you are transporting, the challenge will be slightly different. For example, if you are building a very small CubeSat,
Hmm.
people just carry it in commercial grade carry cases like Pelicase or Pelican. I don't know if you've heard of that.
Yeah, I've heard
So
few
these are
things.
just commercial grade carry boxes that are built by American companies. You can throw them from a 50-story building and nothing will happen when they fall down.
Right, right.
So for CubeSats and very small satellites, that is sufficient enough. But
Hmm.
then suddenly, if you say that my satellite is 100 kilograms, 500 kilograms, or even 5,000 kilograms, uh, the challenge is quite different if you have to build that. So there are extremely specialized people who build carry cases
Hmm.
for these kinds of equipment, so that they can be transported from where it is built to where it will be launched.
Okay. Uh, so there must be companies that make jigs as well for satellites, but it
Yeah,
looks
yeah.
like yeah, okay.
I mean,
So
with all of this, you have to monitor everything, right? So, for example, ISRO does it for its own satellites. They have their own vibration measurement unit. Um, so everything on the way from Bangalore to Sriharikota or wherever, from Chennai to Sriharikota, if they're transporting there,
hmm,
um, is all tracked and measured so that they know for sure that there is no damage internally.
damn, that must be like a whole subsystem in itself. Building
Exactly.
it.
I mean, nobody realizes it because obviously with Indian roads, you don't expect to have them flat and straight
Right, right.
without any bumps and everything. So obviously the truck that is carrying satellite equipment, rocket equipment, and everything is going through all of these hills and humps and everything.
Right, right, right. Damn. Uh, like that only I'd once heard, SpaceX mentioning how they spend time, yeah, engineering sensors to make sure there's no contamination between the seals of the hatch and the seal. Like that itself, such a small thing, but so much time must be spent on just figuring out how to do that. Rohan, you have been inside Shar and this mission control. How how does it feel? Can you feel the vibrations? Uh, is the like does it feel like being in any room and watching, or is it different?
It's a completely different experience. You can feel the vibrations, the sound crackling, and even though you're at a safe 8 kilometers away from the launch pad,
Ah,
when the rocket lifts off, when you watch it with your own eyes, the flame is more orange. On
right.
video, it looks more yellowish.
Correct, correct.
So that's one thing. And if the skies are clear, you can actually see first stage separation and second stage ignition with your naked eye. So yeah, it's altogether a different experience, and the shock waves which pass through your body is much more intense. So that gives you a real different feeling there.
Right. Okay. If anybody if the ISRO stream is on, let me know. I'll switch to it. And Astronil is incoming. Okay, okay, okay. Okay. When I saw the launch, I was a bit disappointed because I was very hyped about this whole vibrations and your whole body will move violently and all that. But I barely moved, and
Yeah,
that to Mark 3.
it's not like I mean, you'll feel a better vibration if you are at the Aero show, which happens in Bangalore, with aircraft's afterburner,
Ha 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 ha.
in action. So you'll not get that feel. It is little dampened than that.
Right. Uh, it does look weird because it feels like a huge building is coming slowly up. It's worth going once. I don't know if
Yeah, but
twice, but
imagine, how big the Starship will be compared to PSLV or
right.
even LSV Mark III. You're talking about, I don't know, like 10 times, 20 times.
Correct. But it feels like we could only see the ISRO's launch properly because of the solids. I think once you have a transparent exhaust, it will be less dramatic
Yeah,
than
you
watching
can't
a
see
train.
the smoke trail, but you can definitely feel the vibrations.
Yeah. Any one of you, uh, I mean, you all have the highest possibility to watch a Starship launch. You all made explicit plans anytime that we'll watch a launch, Starship specifically, or you all plan to in the
I mean,
future.
you can always go. I think it's in Texas, right? So you can always go watch it. It's not like a big thing, and more or
Hmm.
less all of these facilities are also open. You don't need like registration or anything as such. There's hundreds and thousands of people come to watch this stuff in the US. There, yeah. I like this tour that Everyday Astronaut
Yeah,
did
yeah, yeah, yes, yes.
of the whole facility and what you can do, and especially like a tour of what to expect when you're visiting Starbase.
Yeah, that was a very good, like if anybody is going to watch, they can watch. It was too good, that tour. But that whole
Yeah,
area
but what
feels
I've heard is
deserted.
that the no, I've visited the Florida launch pad.
Huh.
Um, yeah, so that was one. I've also visited the when I was working at the German Space Agency. I had a chance to visit the V2 launch pad.
Oh, wow.
So obviously, that is in a small island in Germany called Peenemünde, and that's where the first V2 rockets were launched out of. That place is bombed to death by the Allied troops. So it has been bombed so much that civilians are not allowed to go into that area
Damn. Okay.
because the amount of unexploded bombs
Huh,
that
huh,
are
huh.
lying underground are so much that they decided just not to spend the money in cleaning up the place.
Oh, okay, okay, okay.
So you can only go there if you are working in a special organization and you have special permission.
Hmm.
And since we were at DLR, then we got that, and you have to sign a waiver saying that if there is an unexploded bomb and it goes off when you're there, the insurance will not pay for you.
Damn. Has it happened to anyone has suffered before?
I mean, it's very routine that in a lot of these places in Germany, you will find unexploded bombs, and people will be called to bomb disposal squads will be called because these are bombs from 30, I mean, some 80 years ago during the war.
Oh, I mean, while we are on this topic, what does DLR like do? Like, what are some notable things, kind of like I don't think many people know that Germany has a space agency. Like many people club it into ESA, and those who might have heard might not know what they do.
DLR is basically German Research Institute for Aerospace and Space. They do both aviation and space research at the same time, but they also have dedicated centers for example, for astrophysics, for planetary studies, for space systems, uh, for optics, and so many other things. So they're individual research units. Unlike ISRO, in DLR, it is not a permanent position. Only the group leaders, like in ISRO, you have group directors. They have something like group leaders, and the directors of the institute are full-time positions, as in a permanent position. So most of the engineers at DLR, they are on contract for 2 years, and then it can up to extend up to 6 years. After which they are asked to go find work in the industry.
Interesting way.
Something
So,
which doesn't happen here, right, NP?
Yeah, exactly. So it's like it's not a you cannot once you enter DLR as an engineer, only a very small portion of them end up becoming group leaders and directors, obviously, and the others are all basically trained to become scientists to go into the industry.
oh, that is a very different way to do things. Is why
Yeah,
is it
yeah.
like that? Like, what was the reason they did like that? Because
I
the
mean, the obvious idea is that you once these people are trained enough, they can go apply their knowledge to different industries and create products, right? That can be sold across the world. I mean, Germany as a country, for example, has no big natural resources. The only product they can sell is knowledge,
oh,
right?
interesting.
So, which means that you have to have engineers continuously build things to be able to sell around the world. And so this allows people, scientists, to create knowledge, right? So for example, if you are creating knowledge in, let's say, a battery technology in
Mm-hmm.
space, so you have lithium ion batteries that somebody has developed, nickel cadmium batteries somebody has developed, or hydrogen fuel cells, whatever, and it's developed for some space related purpose. And suddenly that battery engineer who has worked on it on space related constraints may become very attractive for battery technology in automotive sector.
And okay, so okay, if you have to name the some of the like biggest things that DLR has done directly, not the people who left DLR. DLR as an organization.
I would say one of the best things that DLR has done is it has flown one of the most complicated synthetic aperture radar
Kavali Space
satellites.
Center,
I think whose budget is something like
India.
1 year of
The
ISRO's
launch
budget.
of LVM-3M4
Oh,
Chandrayaan-3 is scheduled to take place
So
today,
it's called Terasar, I think.
14th of July
uh,
2023
It's
at
you can
14:35
imagine how
hours Indian
expensive that
Standard
satellite is.
Time
It's something
near the
of the
second
order of
launch pad.
9,000 crores.
The mission intends to place
okay,
Chandrayaan-3,
but
weighing
okay, so this
3,900 kilograms,
this
into
was
an
built over how
elliptical
many years
parking
back?
orbit having a perihelion of
I mean, the life cycle,
150
all of this,
meters, an
this kind of
apogee of
satellite may be built over
36,500
10
meters,
years easily.
and an inclination of
Okay, because often people
21.2
say
degrees.
Gaganyaan is a 10,000
Eventually,
crore
the
project,
destination
whatever.
of Chandrayaan 3
But that
Yeah.
is the
budget is
moon,
given over many years,
located
right? So per year, if you take a per year
384,000
cost, it is
kilometers away,
quite low.
which will be achieved through a series of
Yeah,
orbit-raising and
obviously.
course
But
correction
like it is
maneuvers
very common in very
with
complicated
screw
space
wings.
projects that people start the career in that project and end their career in the
नमस्कार
same project.
Right,
भारतीय
right, right.
So,
अंतरिक्ष
for
विज्ञान
example, if
और
you
इसरो
take
के गौरवपूर्ण इतिहास में एक और
the
अध्याय
recent
जुड़ने
James
जा
Webb
रहा है
Telescope,
जिसके साक्षी हम
Hmm.
सब होंगे
I'm
Right, right,
sure
right.
that there are people who started their career with it and will end their career with it.
Okay, I will introduce Astronil here. Uh, those who are part of the Indian space Twitter community, they know him very well, and you have seen his tweets and data and infographics on my videos many times. So I think my audience knows him very well. Still, Astronil, Maya, if you want to intro yourself.
Hey guys, am I audible here?
Yes, yes, you are audible.
Perfect. So, hi, good evening, guys. Sorry for joining in late, but yeah, I got preoccupied for a moment there. But yeah, it's thanks, Jess, for organizing this live stream and calling us all here. And yeah, I feel I don't know what you guys exactly were talking about, like previously before I joined in, but yeah, I heard the conversations regarding DLR and the usual norms around how the space industries or projects work in general. But yeah, so I myself am a graduate aerospace engineer who has recently completed his master's in space engineering from Germany. Currently, I'm in India right now, trying to make a breakthrough in the space industry. And yeah, with that, like I usually spend most of my time like doing all the stuff that you probably see over Twitter and elsewhere on other social media platforms. So with that said, yeah, that's pretty much about me. And,
Right.
yeah, I
Yeah.
guess we can go ahead and
Yeah.
start
I
discussing
just
about
want
some.
to tell Rohan and Narayan one interesting thing. Me and Astronil were so confident Chandrayaan 3 will launch in 2021 that we planned 6 months before that he'll be guest on Chandrayaan 3 launch stream and like be prepared in 6 months. Like that was the level of hope we had in 2021. 2021, right?
Yeah, I guess so.
Yeah. Wow. So many times it happens, you know. ISRO will often like hype it up, we will believe it, and then you know it's 2 years later,
Right.
right? So,
I mean, it is not. It's not just uncommon for ISRO, right? For common for every space
correct,
agency, right? That they predict something and it's always not delayed at
right.
the end.
And I think it's just limited to aerospace industry in general. Like that's pretty much the norm in like most industries. You promise something, you give your customers or interested parties a certain date, and then then life happens. And it goes on delaying further and further beyond expectations. So,
Yeah, I think this is a good question for Narayan and Rohan. Space planning, like in software domain, we have all this Scrum, Agile, and daily Scrum. You wake up at 10 o'clock, there's a meeting, you tell what I did today and what you do tomorrow. We have 2 week sprints, meaning you'll be given like how many, 4, 5 tasks, whatever. In one sprint, in 2 weeks, this sprint can be different for others. You have to complete those tasks. These sprints are done at a higher level, tasks are arranged at a higher level कि this is my master backlog, these are all the tasks I have to complete. So a question to all three of you will start with Rohan, Narayan, and then Astronil. Space, how does planning work for hardware and specifically space hardware in large teams?
It's a I mean, there's no straightforward answer to it. Thing is, at least if you have a project, at least 2 years back, you should have the seed, sowed to the ground.
Mm-hmm.
And you can't follow a typical project management schedule where on a daily basis you kind of track everything, because as soon as it enters testing mode, right,
Hmm.
then all your planning doesn't make sense, because some new problems which we have not seen before crops up every now and then. So making a micro schedule will not work, and typical 8 hour shift or a job also doesn't make sense. So you might have to put in those extra hours which is needed, because in space the one thing is deadline doesn't move, right?
Mm-hmm.
In India, especially ISRO, they don't follow Elon Musk's timeline, right? If he says 2 months and then it's maybe after a year.
Right.
So if ISRO decides on a launch date, we don't see them postponing a lot. Okay, so with those things
Mm-hmm.
in mind, you can't actually exactly plan if you're trying to do something new. But if it's a repeat mission, then yes, say for example assembling something. But if it is entirely new, there is no said recipe or mantra to follow. That's something we've learned over the course
Right.
of.
No, in software industry, they are very particular that we need this Scrum and Agile is like the whole. There are gurus on LinkedIn giving lectures on all of that. So that is what I was wondering. If there is some, are does this industry also have people like this who are very
No, even if you ask experts from inside ISRO who will advise you, even they will say that following something like a tight deadline doesn't work.
right, right? Narayan?
Yeah, I think it's a very interesting topic because traditionally aerospace industry has been ruled by either government agencies like ISRO, where they need to be very careful with how they spend money, right? So
Mm-hmm.
ISRO cannot function like SpaceX, where they can throw around money as much as they can because they're running on taxpayer money, right? So they're very careful, and that is why they typically use the very well established methodology, which is typically what people call as waterfall
Oh,
methodology.
uh-huh.
So in typical waterfall methodology, what you do is you establish requirements, then you go into design, then you go into implementation, then you go into testing, and then you do maintenance, right? So that's all in series. It's not done in parallel, obviously.
Oh,
If you get your requirements wrong and you go to implementation and going back to the requirements again will be extremely expensive in this at the end. So they
right,
take a lot of time carefully planning all of this, and that's how large organizations typically work, or public organizations, because they have the pressure to handle money very carefully, and also the institutional like legacy that they've built with is coming with it, right?
right, right.
Uh, there's actually a 2-hour podcast on YouTube on how SpaceX uses Agile
Mm-hmm.
as a methodology. And obviously, that comes from them having a lot of people there having a background in the software industry
Right, right,
at the end. So obviously, when you are using Agile, at the end of the day, it comes down to how the culture and the team is working around with these methodologies than the methodology itself.
interesting.
So
Yeah, I think
you
one
can say
thing. Yeah, continue.
yeah, no, I say when people say we are using agile, scrum, waterfall, all of these
Mm-hmm.
things, the theoretical part of that is different from the practical part of this
Correct, correct.
at the
Good
end.
point.
There's a lot of people who look at it from a theoretical standpoint, say, oh, we are implementing, but actually, when you review it practically, they may be using a mix of it, or they
Right,
may
right,
be not really following it to the dot as opposed how it may be, or they may not have any clue as to how to use it because they've never done it before and they're trying out new stuff. But
right.
yeah, I would recommend anyone who's interested in this to go watch that 2-hour video podcast on how SpaceX has basically built agile within its culture.
Yeah, I mean, I think in software, one advantage you have is your costs are kind of almost fixed. That is your resources, your people. Hardware, it must not be working like this. No, you have to plan ahead of time how you'll use your money, whatever is available.
Yeah, that's the sad part of this industry, but which forces you to become vertically integrated, right?
Right.
And for example, when we designed our PCU with or the OBC with experts, right? The microcontroller itself was changed 3 times, as in different architecture, because
Mm-hmm.
you plan something at the end, it doesn't solve all the purpose. Interfacing is an issue. So, as Narayan Prasad said, it's not an open book. And if you want to really be universal with hardware, it really takes experience. You need somebody with experience who can say what can go wrong. So with
Right.
hardware, at least I would say with the especially the current post-COVID scenario, you must make sure your things are in place at least 8 months in advance, because the lead times now is like crazy. What you are getting in 2 months, now it's like easily 8 months.
Wow. Okay.
And still, even in this industry, there are vendors who still say that there's an MOQ,
MOQ?
minimum order quantity. So, for
Oh.
example, a radiation hardened chip which we use. So
Huh.
we did. So as I said, we designed on a failure based mode, right? Failure based design, not a success based design. So which means instead of using a COTS processor, we went for a radiation hardened processor. Okay.
Mm-hmm.
So the lead time for this was like 11 months,
Wow.
which we didn't know. We thought, okay, you place an order, you'll get it in say 2 months. So this kind of screws up your uh, thought process. But yeah, with experience only you can perfect this approach. So there is no one mantra which works for all.
Right. Has this shortage changed the way you think? Are you ordering parts now even beforehand, 1 year, 2 year, planning for
Yes,
future?
yes, as a matter of fact, it has completely changed the way we work internally. Before we were like, we develop core technologies, which is core to Bellatrix, and surrounding peripherals, we thought of, buying and integrating. But now, except your microcontrollers or processors or any passive electronic components, every other thing like a valve or
Hmm.
a pressure sensor, even from pressure sensor to thermocouple, is kind of made in house today.
Okay. Astronil bhai, processes and planning.
Well, surprisingly enough, I'm nowhere close uh, being as much experienced in this regard compared to Rohan and NP. So yeah, I guess I mean, what they've said so far, like I completely agree, and like obviously it's a learning curve because your expectations set you what you want to have a product that you want to buy off the shelf for whatever you're making, or whether you want to develop it in house. And like you said, it's like one of those things that you have a plan in your mind, but it doesn't always really work out. But when it comes to like those processes like waterfall models, Scrum, and Agile
Mm-hmm.
things, I think the model that usually is followed in US, like correct me here if I'm wrong, Narayan. So the process that most of the US aerospace industries and companies follow there. So it's completely different because firstly, like it's tailored to their own market demands, which is significantly like different compared to the ecosystem here in India. If I'm being correct here, could you add anything to it? Because
I would say it's mostly about the institutional background of industries rather than the country in itself. For example, why is Boeing, I don't know, Starliner delayed or by 10 years or something else,
Mhm.
versus why is SpaceX able to get Dragon up so quickly? It's an interesting food for thought because the way that people have followed the process of designing and realizing that particular program, and the way that engineers are incentivized to follow certain processes
Right.
defines the culture there. And that's why, for example, uh, people at SpaceX. I mean, it's also very similar from ISRO, right? If you read a lot of the early books of ISRO, or early memoirs written by people at ISRO,
Mhm.
it was very usual for Sarabhai to create teams that used to compete between each other.
Yeah, yeah, yeah. Recent podcast only, I think you were.
Yeah,
Your solids motor podcast.
yeah,
Yes.
exactly. Or for the fuel mixture and all of these things there. I mean, it's not just that, like in many other things as well. It was very usual during that time that basically Sarabhai would create two or three teams which would basically compete between each other, and whichever provided the best solution would win as a design
Actually,
choice.
most of the early launch vehicles, SLV, ASLV, and PSLV came to existence because those were the
Yeah,
winning teams, that
exactly.
out. Yeah.
Exactly. So now the question is, I don't know what is the current work culture within ISRO, but I can be pretty certain that this level of competition between teams may not exist within the organization.
Right.
Definitely.
In fact, just to add, there's an interesting story told by Dr. B.N. Suresh, former director, both VSSC and IIST. So he was directly hired by Dr. Vikram Sarabhai. So his first job was to open an automatic gate which allows cars to go in and go out. Okay. So since he made that, and then he was made responsible for building the first launch pad. So
Mm.
that kind of a culture, I mean, today I don't think it exists.
Was
Uh,
that launchpad in Amba or in Sriharikota?
This was in Sri Harikota for the SLV.
Oh,
Interesting.
that's nice.
One technical question will start with Astronil. If, I mean, you are a lot into landers and rovers, what if you had to complain, and I love to complain, if you had to complain about Vikram's design or Pragyan's design, what would those be?
Well, I'm only as much familiar about the hardware specifications, and I only know as much about it as the information that ISRO has put out on its website or
Yeah.
launch press kit and
Hmm.
social media. But just going by the ephemeral look of the lander, I feel like, well, certainly this Chandrayaan 3 lander is a definite improvement over the second Chandrayaan 2. But I feel like the landing legs that I see there, the direction or the angle, we call it the bank angle of the legs.
Hmm.
So the banking angle of the legs, where it is attached to the body underneath, I think that angle could have been a bit more steeper, because as of now the angle that I see is an obtuse one, and the forces that act in case the lander falls directly vertical onto the ground, that may happen to have a risk of snapping, or what do you call that, buckling. But we haven't seen the test that they have gone through, or at least like we haven't seen any footage from behind the scenes of their testing. So, I mean, considering that there are 12 struts of legs
Hmm.
attached there, so I feel like that should be strong enough and sturdy enough to provide enough resistance against the cushioning force of the gravity, lunar gravity. But yeah, but that's just from a layman point of view. Uh, that would be, I guess, one complaint, if you want to call it that.
Right. Narayan?
Mhm.
Sorry, what topic exactly were you saying? Would we?
Okay. So you have seen how Vikram looks and Pragyan looks, a lander and rover. And to an extent, we know the specs and how they operate, like the rover goes at 1 centimeter per second. Or uh, if if you had to improve or complain about the design, what would it be?
I mean, look, at the end of the day, I think given the number of changes that ISRO has been able to make for this particular system,
Hmm.
I think it is very substantial. And I'm actually surprised that they were able to do so many changes in so little time.
Right.
Changing, adding more sensors, making the solar panel bigger, adding reinforced legs, increasing the fuel capacity, uh, and then, doing software upgrades. All of these are not really something that you can, it's like, they probably modified, it's this level of redesign is like building almost another spacecraft on itself at the
Right.
end.
Right. Right.
Uh,
In
so it's actually very commendable that they were able to do all of this in such a short time frame, given an organization like them
correct.
at the
It's
end.
like less than 3 years,
So
I think.
yeah, and it's a question of how it's also they. I mean, also they have a budget constraint as well, right? We always have to keep that into mind
Correct.
as well, to a large extent. So they can always do better things. In there is no limit to how much money you can spend in space.
Yeah.
right? So they can always add, I don't know, HD cameras that can do live streaming. They can, because people would like to watch it, they can add many more things, but it's all a question of cost versus this. At the end, what does ISRO want to do out of all of this, right? They want to demonstrate at the end that India can land on the moon at the end. And
Right.
so the current design is simply optimized for the cost for that.
Okay. Okay. Rohan?
Yes, so one complaint, if you ask from my side, is
Hmm.
I would prefer a single engine lander with a throttleable engine. Because from the control point of view, these things can be used to even land on other heavenly bodies. Okay,
Oh,
so yeah, it's much simpler design, but other than that, yeah, by the choice of their fuel, which is MMH and N2O4, where the fuel mixture ratio is somewhere around 1:1 or 1:2, 1.6, something like
hmm.
that. So managing it, because you enter in a 90-degree, angle, and then you have to completely do a turn. So you have to ensure the CG is in place, there is no sloshing,
Right, right.
and the moon doesn't have GPS. So there's both vertical velocity component as well as your horizontal velocity component.
Yeah, yeah.
And for it to correctly choose a landing site, everything, I think this is a very conservative design which will work. Okay, so
Right.
that way, no, if you ask me if it's a conservative design, yes, and it is good, but is it a very efficient success based design? I would say no. Maybe next iterations, it would be better if it has a single engine, because India is also planning to put something on Mars as well.
Correct.
Yeah.
And also, just to add to all of this, based on your interview with Somnath as well,
Hmm.
it's clear that the central part of all of this is it's a GNC problem, a guidance and navigation problem,
Correct. Correct. Yes.
right? So it's a question of how your software is reacting to the sensors around the boundaries that you have set
Correct. Yes. Yes.
for the landing.
Right.
So regardless of what all happens, the core bit of all of this comes down to the GNC algorithms and how it works in loop with the hardware.
Right. So as of now, you could say Chandrayaan 2 was a software problem. At least what
Yeah,
you are saying.
exactly, right. Because at the end, it's often in these kinds of complicated missions. Uh, it is very, I mean, given that ISRO has very good legacy of operating in the geostationary orbit,
Hmm.
you could imagine that their hardware could work in interplanetary missions per se, because they are very good at geostationary satellites that have been working for 15 years
Right.
with those radiation doses that they are exposed to. But then the challenge really becomes on how you entirely design your GNC to work with the software that you are going to build against the hardware that is there. So this is the typical challenge that every other company has, right? If you imagine, this is the central problem of that SpaceX has solved with the landing.
Right. Right. Right.
It's a GNC problem at the end. And so it's really about, because typically hardware teams and software teams in the space industry have worked disjointedly
Oh.
at the end. And
Hmm.
and as these new and complicated things come up into place,
Hmm.
there is a close knitting that is needed between those two teams to understand each other and to work with each other to make things work.
Yeah. I think this problem is in conventional software companies as well, but in different
If I
domains.
may
Like
add something here.
yes. Yes.
So a lot of these software problems that we see, the spacecraft facing, a lot of it also boils down to the deficiency of proper hardware testing facilities or the lack thereof that we have in ISRO. So, for example, with the test rig of Chandrayaan 3, they have made a makeshift sort of crater test bed next to the
Hmm.
vehicle assembly building. If you might have seen that.
Yes.
So it's very close by, next to the vehicle assembly building. So there we have a certain size of land mass, so where they have built artificial craters, and besides that they have a crane, your usual construction crane, and using that they have hung down the test rig or the engineering model of the lander, and that's how they've been testing their landing software, how gently they can land down, and like how good is the ability of the software and those hazard detection and avoidance cameras to detect craters, boulders, and all these sorts of obstacles. So I feel like if you compare those such facilities with the likes of NASA or the one that China uses, they have a proper big test rig with good amount of redundancies built in and other sorts of fail-safe mode that so you can push your you have the option to push your software to the limits.
Right.
uh, right now what I see is ISRO is having a very conservative approach where they are uh, trying to, or at least I think that's how they did it with Chandrayaan 2, where they uh, went ahead with an approach which is very conservative in nature, as in there were not enough redundancies built in, which is what we are
Hmm.
seeing as improvements in the current mission. Like we have two extra antennas right now because last time it was thought of
One.
that the lander might have flipped onto the side. So what if the antenna got damaged? So let's
Right.
have another antenna on two other sides. So even if the lander is not standing
Correct.
straight, one side could still have a working antenna in all probability. So all these fail-safe modes that we see in this iteration, these are only the result of the shortcomings that we had during the development of the second Chandrayaan mission. So I feel like that is something that we could choose to pour more money into it, considering that going down the line in the future
Correct.
we'll be making even bigger and more efficient and all different sorts of interplanetary landers.
Yeah, this was a good opportunity to consider that in investment into the budget as well. A dedicated lander testing facility.
Right,
Yeah.
exactly.
Yeah, I think what would be very interesting to do as a thought process, as a thinking process, is maybe you can also do a video around this. Is if you can speculate on how the failure analysis committee would have looked at the Chandrayaan's 2 results,
Hmm.
right? If you were to be on that committee, what would be the thing that you would look at to say that what went wrong at the end? And my guess would be that
Hmm.
uh, the first thing that people will look at is the GNC algorithm
Yes.
at the end, because at the end, all the design changes that have been made are driven from what boundaries did the software work under uh, that created this feedback loop.
Right. But
So,
if you see SSLV FEC,
uh-huh.
there it feels like they had a issue whose root cause they did not know, and they worked around it. Like why INS saturated that they did not know. But like they built Navik as a backup to the inertial navigation system. Then they added additional dampening to the fourth stage, and oh, there was one more thing. But regardless, the fixes were around that issue. Chandrayaan 2 feels like that they don't know the core issue.
No, I mean, I would disagree with you there, because
Hmm.
I think they probably exactly know everything that they need to know about this. My speculation around the fact committee would be that they must have done an extensive code review around the boundary conditions in which the code was written to work in loop with the hardware around this.
Hmm.
And because this is the most challenging bit in all of these missions, that you build code with certain set of boundaries in this GNC to work in certain ways, and obviously, you can write code for 10 years, 20 years to take every scenario, everything, make it everything refined and so on, right? But at some point of time, software needs to be frozen
Correct,
at the
correct.
end. And so my speculation would be that probably like 80% of the time that the failure analysis committee would spend on would be in looking at the code review around the boundary conditions and how the basically the GNC code took into account the sensor data to
Hmm.
then provide feedback to the actuators.
Okay. Have you all anyone
Well,
seen Luna's? Yeah, Nirvay, say.
Well, I happen to have a slight difference of opinion here, if I may say so. So here I would like to, slightly agree with GS here that yeah, it does feel like that they may not have exactly precisely pinpointed the error and where it might have been located. They may have been able to successfully, lock down on the area where they need to work more, considering the data that they might, depending upon the data that they might have received during Chandrayaan 2's descent. But if you go back and listen to statements given by the previous chairman, Dr. Shivan, he continuously used to say every time he was asked what was the failure of Chandrayaan 2 and why exactly the code, performed differently than it was supposed to. And he would always use this phrase that something unknown must have uh, been the issue. As in, like, the exact cause or the exact shortcoming of the code is attributed to something that they are not entirely aware of, or at least they weren't aware of at that point of time during his chairmanship. But if you, go back and listen to his statement, it feels like they know for sure that the error has something to do with the guidance navigation and the code and its limits, its tolerances. But what exactly caused that error to offset uh, and led to that erratic behavior of the lander during the last few minutes, that may or may not have been, precisely, because if they would have been able to locate the precise error, then we might not have seen the improvements on the lander on all the other different aspects. For example, I have seen papers where some ISRO scientists has attributed the cause to fuel sloshing during the descent, because the lander has to turn from a horizontal position to vertical firing position. So, and I have seen papers where structural strength
अब हम
has
उड़ान
been
से 1 मिनट
attributed
की दूरी पर
as the probable cause of the
Right.
failure. But yeah, so
All sequences are
I
Okay.
don't know, like
is ready.
I
maybe after
think
4 years
Be ready.
we
able
are
to do it, but
close. I think we are
yeah,
close
we're
to the
less than
launch.
10 years.
We listen in, and I
L110
don't know if you all
VSPP
can
open.
listen to my audio. And
I'm moving
secondly, we
99
have
open.
almost 6,000 people watching, which is a new record, which is a lot of people.
Real-time programs activated.
That's
L110 VSPP open.
Okay, y'all can mute your mics for now. I'll tell them.
Lift off normal. P1
Here
tracking.
we have a majestic liftoff of
R2 tracking.
LBM-3 M4 rocket carrying India's prestigious Chandrayaan 3 spacecraft.
P2 tracking.
प्रज्वलन और सफलतापूर्ण
Damn,
उत्थापन
congratulations.
LVM-3 M4 रॉकेट का। यह
Wow.
भीमकाय रॉकेट
Oh,
आसमान को चीरते हुए अपनी भयानक दहाड़ से चारों ओर कंपन उत्पन्न कर रहा है। इसे हम यहाँ महसूस कर सकते हैं और यही दहाड़ है जो वैज्ञानिकों को रोमांचित करती है। LVM-3 के उत्थापन के साथ ही हमारे अंतरिक्ष यान चंद्रयान 3 की चंद्रमा की यात्रा प्रारंभ हो चुकी है।
As the rocket is soaring through the clear skies, every second moving closer to the accomplishment of the most important milestone in its mission to moon. Every Indian witnessing the launch live is content with the feeling of watching history in the making.
चंद्रमा की सतह पर अपना छाप छोड़ने के लिए चंद्रयान 3 अपने मिशन को पूरा करने निकल चुका है। वर्तमान में दोनों S-200 स्टेप-ऑन बूस्टर सामान निष्पादन करते हुए अपनी निर्दिष्ट कक्षा की ओर बढ़ रहे हैं।
The S200 motors thrusting simultaneously, generating a peak thrust of close to 6,000 kilonewtons in vacuum. They are made
P2
of
change over to
HTPB
SCPT2.
based solid propellant, 204.5 tons in each strap-on, close to 2 tons of propellant being burnt each second.
S-200 स्टेप-ऑन बूस्टर्स का
L1
कुल
turn stage ignited.
प्रज्वलन काल 126 सेकंड का है और अभी अभी घोषणा की गई L110 स्टेज का भी प्रज्वलन शुरू हो चुका है।
Apart
L1
from
turn
the
stage
strap-ons,
performance normal.
the core stage has also commenced its operation. This stage, based on combination
200 stages are separated.
of hypergolic earth storable liquid
Loop
propellants
guidance initiated.
UH25 and N204. Now the S200s have been separated.
घटनाक्रम के अनुसार यह यान इस यान से S-200 स्टेप-ऑन बूस्टर्स को सफलतापूर्वक पृथक कर दिया गया है। यह काम सेपरेशन मोटर्स की मदद से किया जाता है। इसके बाद L110 तरल नोदक पर आधारित और विकास इंजन के साथ यह चरण सामान्य निष्पादन करता हुआ अपनी उद्दिष्ट कक्षा की ओर बढ़ रहा है। अभियान क्लोज लूप गाइडेंस के अंतर्गत है।
L1 turn stage performance normal.
The trajectory of launch vehicle is closely following the prediction.
Payload fairing separated.
जी हाँ, पेलोड फेयरिंग को पृथक कर दिया गया है यान से, क्योंकि यान अब 114.8 किलोमीटर की ऊंचाई प्राप्त कर चुका है। इस चरण का कुल प्रज्वलन काल 200 सेकेंड होता है और इस दौरान यह करीब 1600 किलो न्यूटन का प्रणुद उत्पन्न करता है।
We are 220 seconds past the launch time. Current altitude is 135 kilometers. In the 200 seconds of its operation, the L110 stage carries the rocket up to 175.5 kilometers altitude and imparts a relative velocity of 4.18 kilometers per second, that is 250 kilometers every minute.
L1 turn stage performance normal.
LVM-3 M4 रॉकेट का द्वितीय चरण पूर्णतः सामान्य निष्पादन करते हुए इस चरण में कुल 113 टन के तरल नोदक भरे जाते हैं। N204 तथा UH25 अर्थ स्टोरेबल प्रोपेलेंट को ईंधन के रूप में प्रयोग किया जाता है इस चरण में।
Stage ignition is authorized.
अगला चरण C25 का प्रज्वलन भावी है।
+5 minutes.
L1 turn stage thrust cut off and separated to C25 ignition command. 25 ignition confirmed.
That's a piece of really good news that the third stage has started its operation. The C25 stage has been ignited.
जी हाँ, एक बहुत ही जटिल प्रक्रिया होती है क्रायो इंजन का इग्निशन और इसके प्रज्वलन के साथ ही तालियों की गड़गड़ाहट से गूंज उठा है मिशन नियंत्रण कक्ष। तृतीय चरण C25 वर्तमान में प्रणोद उत्पन्न कर रहा है। पूर्णतः सामान्य, सभी तंत्र पूर्णतः सामान्य हैं।
118 kilonewtons thrust in vacuum is what the stage develops with its 28.6 tons propellant combination of liquid hydrogen and liquid oxygen. Present
Cryo
altitude
stage
is to
performance normal.
तृतीय और यह अंतिम चरण है इस यान का C-25। यह क्रायो ईंधन पर आधारित चरण है जिसमें लिक्विड हाइड्रोजन लिक्विड ऑक्सीजन का इस्तेमाल होता है। इसमें कुल 28 टन का क्रायो ईंधन पूरी सुरक्षा तथा सावधानी के साथ भरा जाता है। इस चरण में 186 किलो न्यूटन का प्रणोद उत्पन्न होता है और यह करीब 640 सेकंड तक प्रज्वलित रहेगा। इसमें दिशा नियंत्रण के लिए इंजन जिम्बल का इस्तेमाल किया जाता है। क्रायो ईंधन का विशिष्ट आवेग 446 सेकंड के करीब होता है।
currently the rocket is at an altitude of 210 kilometers.
Plus 7 minutes.
While there is no much variation in altitude, this stage will add to the relative velocity immensely.
Yeah, so far it's been
Cryo
a
stage
perfect
आइए
performance
अब
text to
आपको
normal.
launch. No?
पेलोड के बारे में जानकारी देते हैं।
Yeah.
लैंडर
Not
मॉड्यूल्स
even
पे
a
कई वैज्ञानिक प्रयोगों के
Yeah,
लिए
these are
पेलोड्स
proven
लगाए गए
engines,
हैं।
right? So
yeah.
yeah,
India's prestigious lunar landing spacecraft Chandrayaan 3 moving
What's
closer to its intended
yeah.
injection spot in the orbit.
Yeah, I mean, considering that they could
The
pull it off
propulsion
in
module
4 years
provides
and
propulsion for
still
earthbound
come up with so
maneuvers,
many different
translunar
ways
injection,
that they could
and
improve the
moonbound
lander or
orbits.
at least reduce the
It also has a payload to study
you
the
know
spectral and polarimetric
failure,
measurements of
things
Earth
like that.
and lunar
That's
orbit.
commendable on its own.
The
So
abbreviated name of the
yeah,
payload is SHAPE. Among the payloads of the lander module, the following are
and
included. A landwehr
into
probe
account.
called
So
Rambha
the
to
delays
measure
due
the
to
near surface
the
plasma
2 years of
density, that is, the
pandemic.
density of ions and electrons, and its changes with time. The second payload is Chandra's surface thermophysical experiment or CHASTE to measure thermal properties of lunar surface near polar regions. To measure the seismicity
plus
around the
9
landing
minutes.
site and delineating the structure of the lunar
Yeah,
crust
it's a
and
big day,
mantle,
not just for
payload
space enthusiasts, but
ISL,
for every
ILSA is
Indian.
there.
In fact, for the entire
The
global space
rover, after
community.
its descent, will further the
Cryo
scientific
stage
study
performance
objectives
normal.
through its own payloads. For better understanding of chemical and mineralogical composition of lunar surface,
yeah.
LIBS or
Now in
laser
my office,
induced
4
breakdown
different
spectroscope
conference
is
room, it is
included.
being streamed.
Another payload is the
So
alpha
you can
particle
imagine the
X-ray
excitement.
spectrometer.
जी हाँ, लैंडर मॉड्यूल में 3 पेलोड हैं, रोवर में 2
Yeah, if you recall,
और
the
मिशन मॉड्यूल में
previous landing
1
was in
पेलोड
midnight and people were
भेजा गया
awake.
है।
Yeah.
चंद्रयान 3 के स्वदेशी लैंडर और रोवर में
Correct.
नितंभारों का इस्तेमाल किया जा रहा है। यह अंतर्ग्रही मिशन के लिए भी आवश्यक तकनीकों का प्रदर्शन करेंगे। लैंडर के पास यह क्षमता है कि वह चंद्रमा की उबड़-खाबड़ सतह में भी
Also,
And
if
a
you
lot
look
of
at
सावधानी से
the
उतर
news,
सकेगा
I
और
think this
रोवर
is the
को बाहर
heaviest
लाने के
payload
लिए
which this rocket
और
is
संचार
carrying.
सुविधाएं प्रदान करने के लिए सक्षम
3,900
होगा।
kilograms, all up weight.
That's true.
चंद्रयान 3
Yes.
के लैंडर और रोवर में कुल 6 नितंभार हैं। रेडियो एस्ट्रोनॉमी ऑफ मून बाउंड हाइपर सेंसिटिव आइनोस्फीयर एंड एटमॉस्फेयर, जिसे शॉर्ट में रंभा कहा जाता है।
Correct.
यह चंद्रमा की सतह के पास प्लाज्मा के घनत्व तथा समय के साथ बदलाव का मापन करेगा। इसके बाद चंद्र सरफेस थर्मोफिजिकल एक्सपेरिमेंट चंद्रमा के ध्रुवीय सतह के आसपास की थर्मल प्रॉपर्टीज का मापन करेगा। इंस्ट्रूमेंट फॉर ल्यूनर सिस्मिक एक्टिविटी लैंडिंग साइट के आसपास के क्षेत्र में भूकंप जैसी गतिविधियों का पता लगाएगा। रोवर में चंद्रमा की सतह के तत्वात्मक विश्लेषण के लिए
Cryo stage
लेजर इंड्यूस्ड
performance
ब्रेकडाउन
normal.
स्पेक्ट्रोस्कोप और अल्फा पार्टिकल एक्सरे स्पेक्ट्रोस्कोप इसका इस्तेमाल किया जा रहा
7
है।
minutes.
एक बहुत ही दिलचस्प वैज्ञानिक निर्धार है शेप स्पेक्ट्रोपोलैरिमेट्री ऑफ हैबिटेबल प्लैनेट अर्थ
So
जो
what
सूचनाओं
binds us all
और
together is passion.
परावर्तित
So you have to ensure
पर्यावरण
while
का
you build up
विश्लेषण
a team,
दूसरे जीवन
uh,
सहायक ग्रहों को खोजने में
find for
मदद
that
करेगा
passionate soul. So then your job is easier. Yeah.
Yeah,
And
yeah.
space is one field where they are naturally, passionate, right? It just comes. So that makes us our life
वर्तमान
easier
में T20 से
than compared to
इंजन
somebody
कार्यरत
working
है
in software, right? IT
और
services.
पूर्णतः
Right,
सामान्य
right.
प्रदर्शन कर
Yeah,
रहा
so
है
here
कम
that makes
प्रमोटर
our
से
job easier.
700 से
And
मीटर दूरी पर आ चुके
also
हैं
to
सापेक्ष
lead a
गति
team,
6.5
you
किलोमीटर
should
प्रति सेकंड
be
ऊंचाई
one on one with
191
everybody. So that
किलोमीटर
best example I'll give you. In the previous launch, we did face a software glitch,
As
right?
we
Right,
have
right.
told
Because
you
you're
about the
close with
Chandrayaan 3's
the person who
upgrades,
implemented the software,
the aspects of
Hmm.
he
enhanced
came and
robustness through
admitted that
extensive ground tests and simulation.
old code was
During the
burned
last
rather
phase
than
of
the
landing, the
final
module
code,
will have a vertical velocity of less
right?
than
Oh,
1
oh.
meter per second and horizontal
So you
velocity
also
of
come
less
up with a lot
than
of
zero point 0.5 meters
openness
per
inside the
second
system.
from a
So
height of 3
one-on-one,
meters. The
with the
lander
team is
decks
very
are
important.
designed to be robust enough to
So
drive the
that's
impact.
something we ensure at
The cameras
Bellatrix,
are tuned
that
to
we
take
remain as
pictures ahead
horizontal
of
as
the
possible.
landing and enable intelligent
Right.
decision making for
Yeah,
Narayan
but
sir?
choosing
it's
best
not an easy
locations
journey,
and
right? It's
avoiding
you
craters
also
and
learn
boulders on
through
ground
through the
surface.
process.
Yeah, that only
The
like this
successive
this feels
pictures
so
will
tough
also enable the craft to determine
because
its horizontal
everyone wants to
and vertical
progress only at the end of
velocity
the day,
in
and
real time.
Correct.
it becomes
When we
like
started Bellatrix, I thought technology is
Laser Doppler
difficult and man
velocity
management
sensor
is
is an
easy.
upgrade in
But now I
Chandrayaan
would
3
say
over its
HR is
predecessor.
very difficult.
It helps to determine
right, right.
instantaneous velocity of craft.
Yeah,
Narayan
I
sir?
think
This ties into the behavior of
for at least
Chandrayaan
in
2
our
in the
case,
last few
what
minutes of its descent.
we, as
Has
Rohan
revealed
said,
to the
I think most
scientists
people who are in
the
the space
necessity for
industry are in it for
upgrading the
the
guidance
passion
algorithm.
than the money
Inputs from various
as
sensors
such,
are
because
used by the
in fact,
autonomous
space industry
calibration
pays really
guidance
bad.
algorithm
If you want to
of
work in it,
Chandrayaan 3 to
it's
plan
much
the
better
flight
you work
path
in,
to the most
I
suitable
don't know,
landing
like
spot.
cybersecurity, IT industry, or other
The
places
guests of
where
Chandrayaan
you
3 are
probably can
capable of
expect a
more
much
casual travel.
bigger salary, 2 times, 3 times the salary that normally the space industry pays.
Right.
Most people who work in our industry are the ones who are really passionate about space and the work that they get to do, rather than optimizing
हम
for the
प्रमोशन से
uh,
870
salary
फीट की
that
दूरी
they are
पर
going to
पहुंचे
get
हैं
at the end.
करीब
Right,
950
right.
I think,
फीट पर
especially
अगले चरण
for
पैराशूट
me, I think within our
को
own small
लिफ्ट ऑफ कर
team,
दिया जाएगा
the most important bit, and we are a completely remote team, so we have
और
team
उचित
members
प्रवृत्ति
who are
प्राप्त कर
now spread across
चंद्रयान 3
5 different countries.
यान से
Mm-hmm.
पृथक कर दिया
So, and
जाएगा
we only see each other once a year.
चंद्रयान
Okay.
3 को
So
जमीनी
it
अंतरिक्ष में
already adds
15 मिनट
a
के
very
बाद
big level of
ऑर्बिट में
complication because of that, right? Because you need
लॉन्च
to have
करने
a
के पश्चात
extremely high level of trust.
770 किलोमीटर
We
पर
also
चढ़ेगा
don't have any
कक्ष
trackers
प्रणाली
on
का भी निर्माण किया
inputting
जाएगा
time or tracking people, how much time they're spending
पांचवें
on
भाग
work.
में यह
Right, right.
All
उपग्रह
these things, we
पृथ्वी से
don't have any
परिक्रमा
of
की
these
ओर
kinds of
प्रस्थान
very
करेगा
traditional
जिसे हम
tools
ल्यूनर
that many
ट्रांसफर
companies
ऑर्बिट के
use.
नाम से जानते
So
हैं
which means that there is an extremely high amount of trust
फिर
that
5
we
अगस्त
put
2023
on
को
our
यह
team
चंद्रमा की
members
कक्षा में प्रवेश करेगा और फिर
Right.
at the end.
क्रमशः 5
So
चरणों
it's
में
really a
एक
question of
स्ट्रैटो प्रोपल्शन मॉड्यूल
telling people
चंद्रमा से 100 किलोमीटर की वृत्ताकार
what the
कक्षा में
company needs
स्थापित
to
किया
achieve,
जाएगा
so that
यान
every one of
उपयुक्त
us
समय और अमृति में लैंडर
is
मॉड्यूल
able to
को
go home
लिफ्ट ऑफ
happy,
किया करेगा
than
और
do all
23
of this, right?
अक्टूबर
So I mean,
2023
there's a
को
very interesting
चंद्रमा की सतह
analogy
पर
that
लैंडिंग की
I
प्रक्रिया
like
शुरू
very
की
much, like,
जाएगी
right? So typical corporate mentality will be like people using other people as ladders and growing on top, and like having a crab mentality in the will
Right,
at the
right.
end.
Yes.
But the
We have come
organization that
close to
really everyone
900
needs to
seconds
build
after
is
the
like the
launch.
military, right? If you look
Currently,
at
the
the Indian
T-25
Army or
stage
any
of
other military,
thrusting.
people trust each other, because if the person who is next to
The
you is
launch
shot, you
relative
will be the next
velocity
who will
is
be dead
9.29
Mm-hmm.
kilometers per second.
at the end. So if you bring that mindset to your organization, that there's such a high level of
अगले
trust
कुछ ही
that
क्षणों में हम
if I don't
देखेंगे
look out for my other colleague and he doesn't look out for me, then every one of us
N4
just
रॉकेट का
collapses.
चंद्रयान
Right.
को उद्दिष्ट कक्षा की ओर ले जा रहा
That
है
thinking is not existent
और
in corporate
उद्दिष्ट कक्षा
organizations
प्राप्त होते ही और उचित अभिवृत्ति प्राप्त होते ही
at the
चंद्रयान
end.
3 को अंतक्षेपित
Yeah,
कर दिया जाएगा
I think we should focus on the stream at this moment because we have
I
soon
yeah.
Chandrayaan
Satellite
mission
injection
coming.
continues. Handing over to mission director.
Okay, done.
Mission Director,
Yeah,
the
now only
LVM-3
hope it
M4
reaches moon
Chandrayaan mission
successfully.
accomplished its precise satellite injection conditions. LVM-3 M4 mission is successful. Jai Hind.
The launch has also added a feather in the cap of LVM-3 rocket. You can
That's
watch the
wonderful.
jubilant congratulatory gestures of ISRO scientists in the Mission Control Center.
जी हाँ, चंद्रयान को सफलतापूर्वक अंतक्षेपित कर दिया गया है, लेकिन
So
चंद्रयान
quickly
3
It would
की
be
marked
यात्रा
cool if
as
अभी जारी
ISRO
है।
would have this, like I
अब
think
इस मिशन के बारे
Tesla,
में
when
हम अध्यक्ष
SpaceX
महोदय
launched
से
Tesla
सुनेंगे और हम
into
आपसे
space,
आज्ञा
they
लेते
had
हैं।
this website tracker, I think,
the,
We
of
sign
where
off.
the
yeah,
Up
Tesla
next
was.
is
yes,
address
yes,
by
yes.
It
Secretary
would be so
TOS
cool to
Chairman
see this
ISRO.
on Chandrayaan 3, right?
Correct, yes, totally. Or even if they could provide like a live camera view. I don't know
Yeah,
if
yeah.
it's a TTC restriction, but they have so many TTC antennas on this.
There is a
Yeah, I
user
mean,
on
even if
Twitter
they
who has
captured frames,
made,
right?
there is
Yeah,
actually a Twitter user who has made a full-on website using the
yeah,
ephemeris
he had
data
made
from
for
GPS
two as
horizon.
well, right? Sankara
Yeah,
dot net.
Vishwanathan is his name. Yeah. In fact, I am also working on making a couple of animations where I can show you how the apogee raising maneuvers are
Yeah,
going to be conducted in order. And
yeah.
then,
At the rate astro underscore Neil underscore है ना? Or is
yeah, and
astro.
Congratulations, India.
Okay, let's listen to chairman.
Chandrayaan 3 has started its journey towards moon. Our dear LVM-3 has already put Chandrayaan 3 craft into the precise orbit around Earth. 170 by 36,500 kilometers was its intended target orbit, and it is precisely there now. And let us wish all the best for the Chandrayaan 3 craft to make its further orbit racing maneuvers and travel towards moon in the coming days. So let me wish all the very best to Chandrayaan 3 for its further journey towards moon. Before that, let me introduce the team behind this mission, the mission director, Mr. Mohan Kumar, and also the project director of LVM3. And we have also the mission director for the Chandrayaan 3 craft, the project director of Chandrayaan 3, Veera Muthuvel. So over to them, Mohan.
Thank you, sir. Honorable Minister of State for Science and Technology and Departments of Space and Atomic Energy, Dr. Jitendra Singh, respected Chairman ISRO and Secretary Department of Space, former secretaries of the department, invited dignitaries, respected dignitaries and invitees. I am very happy to report here that the LVM-3 M4 vehicle has injected the Chandrayaan-3 satellite to the precise orbit, and once again the vehicle is proved to be the most reliable heavy lift vehicle of Indian Space Research Organization. Congratulations to the teamwork of ISRO family. I would like to appraise three things here. The vehicle systems are in the continuous process of quality improvement, especially in the event of our human rating efforts towards making the systems reliable. Secondly, the payload also, capability of the payload also is improved by mission strategies as well as vehicle engineering approaches. We are in the process of increasing the launch frequency of this vehicle considering the national requirements as well as satellite demands. Here, so many improvements we have incorporated in this vehicle. For example, the S200 nozzle, they are processed exactly as per the human rating standards, enabling us to have 100% NDT, and the inherent pocket erosion characteristics are removed. The L100 stage Vikas engine, mostly it is 100% qualified to be the human rated engine with indigenously developed LET throats, and the pocket, the back wall gas entry also is eliminated, and it is a perfect system. Yes, and CE20 stage also is perfectly actually, sir.
Good. So we will describe all those details later because of shortage of time.
Yes, sir. I take this opportunity to thank all the mission executives because mission executives for all the supports all along the launch campaign process as well as the launch. Once the launch manifest is released and mission executives are identified, really this is a penance of so many across the ISRO centers, our launch vehicle centers, VSSC, LPSC, IPRC, IASU, SDSC, SHAR, URSC and SAC, along with all our industrial partners, major players to the small-scale industries who supply us with all the deliverables in time, quality products, the suppliers of chemicals, propellant ingredients, suppliers of avionics systems, and our own GOCO facility operators. Actually, the industrial manpower is really our ISRO's virtual manpower. Everybody's efforts went into this, and also the prayers and best wishes of all our seniors, retired executives, everyone's prayers and our own family members. I take this opportunity to pray God Almighty for all the blessings in the form of this success, which was the penance by the ISRO family for last 73 days. And my prayerful pranams for the successful continuous operations of the Chandrayaan spacecraft, for its safe and soft landing on lunar surface and further experiments. Thank you. Jai Hind.
Respected Chairman ISRO, Center Directors, dignitaries and my team Chandrayaan 3, very happy to note that our Chandrayaan 3 has been injected into an intended orbit with very close orbital parameters. Congratulations and thanks to LVM3 team. And all our spacecraft health parameters are normal, including the power generations in both propulsion module and lander module. Our journey to moon has begun now for the most awaited soft landing. We'll be closely monitoring and controlling the spacecraft from ISRAC Bangalore. Many critical events are lined up, starting from earthbound maneuvers, insertion into the lunar orbit, and separation of lander, and set of deboost maneuvers, and finally the power descent phase for a soft landing. I take this opportunity to thank Chairman ISRO, Director URSC, and all the center directors for entrusting me this opportunity, who have been the motivational and guidance force behind this mission. My special thanks to Chandrayaan 3 project executives, Associate Project Director Kalpana, Deputy Project Directors, Project Managers across the ISRO centers who have provided an excellent support in building the spacecraft. My special thanks to the expert committees for their constant guidance throughout the various stages of the project. I also thank the various work centers and industries who have contributed directly and indirectly to this mission. My special thanks to URSC council members, group directors, deputy directors across the ISRO centers, and looking forward for the soft landing with all your wishes and blessings from the God. Thank you.
We have our Honorable Minister for Space, Minister of State for Space, Dr. Jitendra Singh ji, amongst us during this historic occasion of success of launching of LVM3. So we would like to hear a few words from him. Over to you, sir.
It is indeed a moment of glory for India and a moment of destiny for all of us over here at Sriharikota who are a part of the history in making. Thank you, Team ISRO, for making India proud. And thank you, Honorable PM Narendra Modi ji, for having made this possible by unlocking the gates of Sriharikota and enabling the India's space sector. You would recall, Honorable Prime Minister had very recently said, sky is not the limit. And living by his words, I think the Chandrayaan today has gone beyond the limits of sky to discover the unexplored horizons of the universe beyond. Ladies and gentlemen, this day today, the 14th of July 2023, is also a day of vindication. Vindication of the dream that Vikram Sarabhai saw 6 decades ago. He might have been short of resources, but never short of confidence. And when we see those pictures of a launcher vehicle being carried on the carriage of a bicycle, without any remorse, without any slightest embarrassment, that is because Vikram and his team had faith in themselves, faith in India's potential, faith in India's acumen. And today, here, we are vindicating and we are reiterating India's indigenous capabilities, living up to the ideal of Atmanirbhar Bharat. And before I conclude, ladies and gentlemen, as Mother India enters into the next 25 years of this Amrit Kal, she pledges to play a leading global role in the emerging world scenario of 21st century. Thank you and congratulations once again.
Thank you, sir. We will also introduce the directors of the centers who have done all those great work of building the rocket, building the scientific instruments for Chandrayaan 3, the Chandrayaan spacecraft itself, and made all those critical systems, and also the agencies who are going to handle the rest of the mission part, the tracking and the ground stations, and all those teams are here. So I request the directors of those centers to join. First, Director of Vikram Sarabhai Space Center.
Good afternoon, India. In last 1 year, this is the 10th mission, including the precise landing of the reusable launch vehicle. So with this mission, this is the 7th mission of LVM-3, the successful mission. With this, the success rate of LVM-3 is 100%. And this is the ideal vehicle for Gaganyaan. Some of the changes that we are incorporating in Gaganyaan, we have implemented here, and the Mark III has crossed the reliability of 0.9 and inching forward. So I take this opportunity to salute the entire ISRO community, especially the VSC community and all launch vehicle centers, industry partners for making the stages, making the sub-assemblies and testing. In fact, this is the 3rd launch of LVM-3 in 1 year. You know, the realizing the stages, assembling, testing, and then launching 3 LVM-3s in 1 year is a Herculean task. I salute the industry as well as all the ISRO centers for this. And I wish all the very best. We know that when the beginning is good, the ending has to be good. I wish all the very best to the Chandrayaan for its solitary journey through the vastness of space and for making a feather-like soft landing in the 4th week of August. Good luck. Thank you.
Dr. Narayanan, Director LPSC.
Yeah. Good afternoon to you.
Sabhi
Event for Indian space program and a proud moment for all the Indians across the globe on this momentous occasion of the successful launch of the Chandrayaan 3. 3-in-1 spacecraft in the required orbit with the highest level of precision by our heaviest launch vehicle LVM-3. After the 2 launches of LVM-3 vehicle this year, this vehicle is realized in the record shortest time. Today, once again, all the vehicle systems have performed, demonstrated the 7th successful launch. As you all know, the entire spacecraft community has put wholehearted effort during last 4 years, and we have realized a marvelous, great scientific satellite. For this mission, the entire vehicle performance is as expected, as predicted. In fact, the precision in which the satellite is launched shows the reliability of this vehicle. And we too have 4 liquid propulsion modules, 2 in the launch vehicle. The L110 stage, C25 stage, it has performed extremely well along with all other vehicle systems. We too have 2 more propulsion modules, one for taking the spacecraft to the moon, another one for soft landing. I think it is already well integrated, the system health is very good. Today's success is the culmination of the dedicated, smart, and hard work of all the ISRO team members and the work culture of ISRO and the review process what we follow. I am sure all further mission operations will be a grand success and we'll have the successful soft landing. On this occasion, let me congratulate and compliment the members of ISRO team, our family members who have really sacrificed, the partners from industry and academia, and the various review fora. Thank you. Jai Hind.
The Chandrayaan craft was built at the UR Rao Satellite Center, so I request the Director of URC to speak.
Good afternoon, ladies and gentlemen. I take this opportunity to first thank my colleagues from the Launch Vehicle Center for providing a textbook-like launch for Chandrayaan 3 on its journey towards Moon. Thank you very much. And as Director LPSC and Director VSSC mentioned, realizing this kind of launch vehicle, third launch vehicle within a year's time is indeed a Herculean task. And thank you very much for the effort that has been put by all the members of the launch vehicle community and the industry supporting them. Coming to Chandrayaan 3, Mohan was telling that it is a penance. In fact, it is a penance of the Chandrayaan 3 team for the last 4 years, which has come today as an outcome. It is sitting like a brain sitting inside the head of a human being on that mighty vehicle. On top of that, that satellite was sitting, and it was such a happy moment to see that satellite getting separated. And our work continues from now for the next 42 days till we reach the lunar orbit and touchdown softly on Moon. So we'll speak the rest of the things after the soft landing on top of Moon. Till then, thank you very much for all the members of the satellite community and the industry for your support, which has been continuing over several years, and I'm sure will continue in future also. Thank you very much.
Space Application Center Ahmedabad plays very important role in our scientific instruments and building of the satellites. Over to Director SAC, Nilesh Desai.
Thank you. Good afternoon, everybody. At the outset, let me compliment Team ISRO for this excellent work, and especially vehicle team as well as the project team. And as we begin this historic journey towards Moon, well begun is half done, as it is said. So I'm sure that we'll succeed in our effort and endeavor to land on Moon safe and in secured manner with a soft landing after 45 days. So I wish all the best to all the people who have contributed directly or indirectly, and especially to the project team, spacecraft team, as well as my team at Space Application Center, who has developed sensors and other hazard detection and avoidance system, which will help for a secured and safe landing on Moon. So once again, I thank all who have contributed in this mission. Thank you.
Director of this center, Satish Dhawan Space Center, is the chairman of the Launch Authorization Board and also realizing the solid motors of this rocket. So over to Director SDSC Star Rajarajan.
Honorable Minister of Science and Technology, Dr. Jitendra Singh, respected Chairman, our mentors and the dignitaries present here, and the entire ISRO family. A very successful launch, and hearty congratulations to all the LVM-3, M4 and Chandrayaan 3 mission. So once again, the Fat Boy has done its job and put a very precisely our prestigious lunar mission Chandrayaan 3 in the transfer orbit. And I congratulate the SDSC SHAR team, because throughout this launch, we had many launch campaigns of 355 and 56. Along with that, we are proud to have this. In spite of the weather conditions here, we have successfully launched LVM-3 in the prescribed launch window time between July 12th and 19th. And we had a very good, smooth campaign here, and all the hearty congratulations to the entire launch vehicle team, as well as for the last 2 months, for hosting the Chandrayaan 3 team here and carrying out all the tests to make sure that Chandrayaan 3 is also ready for the mission. And I also thank our entire logistics team who handled this huge crowd throughout this campaign period, in particular last 2-3 days. And my sincere thanks to the various Indian industries who are now participating in various aspects of solid motor processing as well as the assembly activities of our launch vehicle to make it successful. And I wish a glorious success in the future to come. And I wish, as mentioned in the last week of August, to have a successful soft landing of Chandrayaan 3 lander on the moon surface and to make history. Once again, thank you. Jai Hind.
I request all center directors to join on the podium. Please come, all of you. Can you lower this? Please come here. Please come here. Come. Please come.
Hmm. Hmm. Nil Bhaiya, you're here?
Yes.
Yes, okay. So, जो देख रहे हैं, Naran and Rohan had to leave. Naran had for a meeting, and I think Rohan you'll see on news now. आज आपने देखा लॉन्च बहुत अच्छा था, as in the whole production.
हाँ.
I'll go back later. एक मिनट हम एक्सप्लोर करते हैं ये. कहाँ पे है लॉन्च? Okay, here somewhere. Okay, here.
Wait, stream से ऑफ कर दिया है ऑडियो?
हाँ वो मतलब जा रहे हैं, लोग जा रहे हैं. आपका इको आ रहा
Okay.
है.
रुको रुको.
हाँ.
हाँ.
हाँ, आई एम स्टिल कंफ्यूज कि आपने उस दिन सोमनाथ का एफईसी आंसर सुना. आपने देखा इंटरव्यू, राइट?
हाँ हाँ मैंने भी देखा.
हाँ, वो उसका एफईसी आंसर लाइक कहाँ पब्लिकली कहाँ बोला इट, बोला आई मीन, बट इट इज नॉट वेरी ऐसा टेक्निकल डेप्थ नहीं
एग्जैक्टली
है.
बारे में कह रहा हूँ.
एफईसी रिपोर्ट जब मैंने पूछा सोमनाथ से, एफईसी रिपोर्ट कब रिलीज होगा चंद्रयान 2 का,
हाँ.
ही सेड इट्स ऑलरेडी एक्सप्लेन्ड इन पब्लिक.
No, I think what he means is that he has already explained like multiple interviews and talked in different media persons, and I think that's what he means by like he has already explained the cause of the failure to so many of news anchors and media people. That's what he means by.
Probably.
Not.
बट
Yeah.
फिर मैंने रिक्वेस्ट किया कि एसएसएलवी की तरह पब्लिश करो ना इतना ही तो डॉक्यूमेंट विद डीप
I
टेक्निकल
remember
थिंग.
in video probably from a couple months ago, he said something like it's in the due process of being released and
हाँ हाँ,
sure.
वही मैं ट्वीट ढूंढने गया था, आई कुडंट फाइंड इट. इट वाज टू अ न्यूज़ ऑर्गेनाइजेशन, नॉट ट्विटर पे. ही हैड सेड वी प्लान
Yeah.
टू रिलीज द डिटेल्स सून, चेंजेस.
To that video in case you need that. So he said that it would be released in due time, after going through a certain process and approval and all these procedures. But now it doesn't feel like he's, in a mood to release all that, because he says that so many years have already passed and so much of discussion has already happened. Everything that public needs to know is already in the public domain. So probably that's what he was referring.
राइट।
Funny. Yeah. Mhm.
फाइनली हमारा वो प्लान सक्सेस हो गया भैया, वो इतने सालों से।
Yeah. Pre-COVID या COVID के
हाँ,
टाइम से
कोविड
था।
के टाइम वी वुड हियर रूमर्स इन 2020 2021 में होगा, ये होगा वो होगा, बट वी वर एट वन पॉइंट वेरी कन्विंस्ड कि हो जाएगा 2021 में,
हाँ,
एक्सट्रीमली कन्विंस्ड।
बिकॉज फर्स्ट अनाउंसमेंट जब इन्होंने चंद्रयान 3 के बारे में किया था तो दे सेड कि विद इन 1 year इट वुड बी launched, after making all those corrections
हाँ
and
हाँ, यस
whatnot.
यस यस यस।
1 year से 2 year हुआ तो we felt like okay, now it has stretched enough, so this is sufficiently long enough, so by the end of this year 2021 or 2022 it would get launched one way or the other, but still, like, I'm happy that they could manage to pull it off in the
या
time that they've got. Mm, yeah.
42 days
So,
गोइंग टू बी टफ वेटिंग। मेरा
yeah.
एक ही कि उस मून तक पहुंच जाए, मून के ऑर्बिट तक पहुंच जाए, उससे पहले कुछ नहीं
But
होना
still,
चाहिए, दैट विल बी अनदर इशू।
lots of updates for the burns and translunar injection and lunar orbit injection now.
हाँ
So that should keep us engaged for the time being.
हाँ, आपने, हाँ आपको पूछना था, वो आपने वो एक डायग्राम दिखा था ना इन 3D ऑफ द ऑर्बिट विजुअलाइज्ड,
Mm-hmm.
आई
Huh?
थिंक ऑन ट्विटर यू हैड अपलोडेड अ डायग्राम ऑफ द ऑर्बिट and it was in
Right.
3D showing like it goes below the earth and then goes this way upside. Why was it
Uh-huh.
curling in the end, like वो ऐसा orbit it was curled like a DNA?
वो मून के ऑर्बिट में है ना, मतलब कि वो प्रोब जो है लूनर ऑर्बिट
ओ
इंसर्शन के बाद
वो कर्ल्स वो मून के थे, अच्छा ओके 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 ओके, एंड दे आर रिलेटिवली
उस
मूविंग
ग्राफ में
वैसा।
अर्थ एंड मून नहीं विजिबल है, बट मतलब एटलीस्ट ये पता चल जाना चाहिए कि वो सेंटर में अर्थ है,
हम्म
ग्राफ के सेंटर में, एंड लूनर ऑर्बिट इंजेक्शन के बाद जो कर्ल हो रहा है, लाइक अ टेलीफोन वायर,
हम्म
उसके सेंटर से मून की ऑर्बिट जा रही है, सो मून के चारों तरफ वो ऑर्बिट कर रहा है एज इट इज मूविंग फॉरवर्ड.
अच्छा 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 अच्छा, so that it going round and round is the moon orbit and the moon is moving
हाँ,
forward, इसलिए वो।
यस एग्जैक्टली, अगर तुम उसको बहुत क्लोजली फॉलो करोगे, उसको देखोगे, तो यू विल सी दोस कर्ल्स, जो हीलिक्स है
हम्म
स्पाइरल,
हाँ
वो थोड़ा आगे जाके छोटा हो जाता है, बिकॉज लूनर ऑर्बिट इंसर्शन के बाद वो एपोजी कम कर रहे हैं ना, धीरे
हम्म।
धीरे तो ऑर्बिट का साइज कम हो रहा है, तो वो जो स्पाइरल है उसका भी जो रेडियस है वो कम होता जा रहा है. तुम अगर उसको दोबारा ध्यान से देखना, सो यू विल सी, थोड़ा जूम करके.
और एक और क्वेश्चन, आई थिंक यू विल अंडरस्टैंड दिस, व्हाई डिड सोमनाथ से कि दे वोंट गो बर्न टू डिप्लीशन, क्योंकि वो एक स्टेबल ऑर्बिट चाहते हैं, दे वांट लाइक अ मोर कंट्रोल्ड ऑर्बिट, व्हाई नॉट गो फॉर मोर परफॉर्मेंस, ऐसा क्या है अबाउट लॉन्ग
ये मुझे
ऑर्बिट?
समझ में आया कि ट्रैकिंग रिलेटेड उन्होंने कुछ रीजन दिया था कि परहैप्स की लूनर ऑर्बिट, सॉरी, अर्थ पार्किंग ऑर्बिट इंजेक्शन के बाद ट्रैकिंग से रिलेटेड उनको कुछ टेक्निकल इश्यूज थे, सो मे बी टू फिक्स दैट दे डिसाइडेड कि प्रीसेट ऑर्बिट, डिटरमिन्ड ऑर्बिट साइज होगा, उसी में प्रिसाइजली इंजेक्ट किया जाएगा, नॉट बिगर और स्मॉलर देन दैट, so it probably has something to do with tracking. And currently, soon after the launch, Canberra उसको track कर रहा था, Canberra Deep Space Network of
हम्म
NASA. And उसके बाद Goldstone ने acquire करना चाहिए. So let me go back and refer to the ephemeris to see exactly where it is right now. Both and yeah. बट इस बार तो और भी मतलब सिर्फ नासा और इसरो का IDSN के सिवा ईसा
हम्म
के भी स्टेशन हैं जो कि करंटली हैं, इवन यूके का भी है गून हिली ट्रैकिंग स्टेशन.
अच्छा,
सो हाँ,
अरे मुझे
सो
बोलो दिस टीटीसी, आई गॉट कंफ्यूज, एट वन पॉइंट ही वाज लाइक इम्प्रूव डेटा रेट, but then at other point he's like omnidirectional. TTC antennas, those round to गोल जो होते हैं, those by nature are directional.
नहीं, अभी ओमनी डायरेक्शनल एंटीना इसरो नहीं यूज करता है किसी भी सैटेलाइट पे. सो मॉम के साथ भी यही इशू था कि वो डायरेक्शनल एंटीना ही वो यूज कर रहे हैं. दैट वाज द रीजन कि क्यों वो उसको एटीट्यूड अगर जरा भी डिस्टर्ब हुआ तो वो दे विल लूज द कम्युनिकेशन लॉक. सो इवन विद चंद्रयान इट्स अ डायरेक्शनल यूनिडायरेक्शनल एंटीना. सो इसीलिए तो जो दो एक्स्ट्रा एंटीनाज इन्होंने इसमें लगाए हैं फॉर रिडंडेंसी वो भी डायरेक्शनल ही है. सो उनका रीजन ही यही है कि दोनों ऑपोजिट फेसिंग है और एक ऊपर की तरफ है, तो नो मैटर जिस भी ओरिएंटेशन में लैंडर फेस करते हुए लैंड करे, एटलीस्ट वन और मोर एंटीना शुड बी पॉइंटिंग टुवर्ड्स द अर्थ. एंड जितने ज्यादा एंटीना लॉक में होंगे उतना ज्यादा डेटा ट्रांसफर रेट पॉसिबल होगा. सो बैंडविड्थ भी उससे वो है इंक्रीज होगी.
Okay, I assume a broadcast antenna will take a lot of power.
हाँ, फॉर श्योर. आई मीन डिपेंड्स कि वो किस तरह का डेटा और कितना डेटा वो पर सेकंड या उस पे ट्रांसफर कर रहे हैं, तो उसके डेटा एक्सचेंज रेट स्पीड पे भी डिपेंड करता है.
Okay, like how people track down these weather satellite images. If frequency is known, can people uh, ये encrypted होगा ना? I think इनका डेटा.
हाँ, डेफिनेटली. लाइक ये जो ऑल ओवर द वर्ल्ड जो ग्लोबल डीप स्पेस नेटवर्क्स हैं, ये भी जो डेटा रिसीव करते हैं ये एनक्रिप्टेड है एंड दे पास ऑन टू इसरो who has the sole capability to decode it.
अच्छा अच्छा, ओके ओके, तो ओके. एंड सिंस आप रोवर डिजाइन्स में भी कर चुके हो, why is the speed so slow, like 1 centimeter per second? Feels like
Well, mostly it has to do with the dust kickoff कि अगर जितना ज्यादा रोवर अगर फास्ट चलेगा तो towards the rear side of the wheel वो उतना ज्यादा dust ऊपर की तरफ वो उछालेगा. So and because the lunar regolith is very sharp and very unrefined in its nature and its composition, so it might end up on sensitive surfaces of sensors या camera, yeah, it might start to damage the structure too soon. So that's the reason why they keep it too slow and steady.
okay.
I think जो fastest rover है वो अभी
हाँ,
currently perseverance है, वो भी 5 centimeter per second है. So
वो
yeah.
तो मार्स पे इतना बड़ा इशू होगा नहीं चांद की तरह, ग्रेविटी का वजह से.
हाँ, but then वो भी 110 का rover है. So
अच्छा,
yeah.
okay, I think last question. I think we are already how much? Almost 2 hours, 5 minutes in.
Right.
मैं भूल गया क्वेश्चन. 1 minute.
लास्ट में वो कोई स्क्रीन नोटिस की थी क्या?
कौन सी?
मिशन कंट्रोल सेंटर पे, जिसमें लास्ट में वो सीक्वेंस ऑफ इवेंट्स दिखाते हैं उसका टाइम.
हाँ.
नहीं, मैं वो पूछना चाह रहा हूँ कि बिकॉज आई डिडंट स्पॉट इट. आई वाज एक्चुअली क्यूरियस
ओके
टू
ओके. नहीं नहीं,
ऑर्बिटल पैरामीटर यूजुअली मेंशन्ड होते हैं ना.
सब सीक्वेंस ऑफ इवेंट्स ना. नहीं.
हाँ, पोस्ट लाइक आफ्टर सैटेलाइट इंजेक्शन.
हाँ, I remembered the question. Oh, Somnath sir said they upgraded from 5 ampere hour to 10 ampere hour. 10 ampere hour matlab it's like our power bank. Am I correct? Meaning the size?
लाइक ये उतना वॉटेज है. इट्स नॉट द करंट एम्पेयर आवर. बट हाँ,
Okay.
आई गेट व्हाट यू आर सेइंग.
So does it still, like, is that size still like, how does it work out? Like, what is the real human reference for that rover battery?
I think they have increased the capacity of the battery because तुम अगर इसके सोलर पैनल्स भी देखो, दे आर वेरी डायरेक्शनल इन नेचर. दैट इज कि रोवर एटलीस्ट लेफ्ट या राइट हैंड साइड अगर उसका पैनल फेस करेगा सन, ओनली देन इट कुड एक्वायर पावर, राइट? एंड
Okay.
इफ इट्स रनिंग low on power, then they need to perform a turn, a 90-degree turn, or like by whatever angle it is, they need to turn around so that the solar panels can face the sun. And that alone can take too much of time, if not too much of power. So you know, uh, to rely on sun completely, and in the off chance that you're not getting enough sunlight or other reasons, it's better to have a bigger and more capable battery that you can rely on instead.
Yeah, he said something like that, I think. The solar panel is weak, something like that he said while saying.
एंड अगर तुम वो एनिमेशन में अगर तुम वो नोटिस करो जस्ट आफ्टर टच व्हेन द रैम्प डिप्लॉयज, तो रैम्प के जस्ट लेफ्ट हैंड साइड पे ही वो एक्सटेंडेड सोलर पैनल है, राइट? जो सोलर पैनल जो सबसे बड़ा वाला है
करेक्ट।
जिस साइड पे, जो बाहर की तरफ थोड़ा निकला हुआ है, तो उसकी शैडो रोवर पे पड़ती है. सो आर यू कैन यू इमेजिन व्हाट आई एम ट्राइंग टू से?
यस 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 यस
कि जब रोवर डिप्लॉय होगा और वो अपने सोलर पैनल रेस करेगा बाय 90 डिग्री, half of the rover would be covered, would be under the shadow by that extended solar panel which is just next to it.
करेक्ट करेक्ट
है ना? तो उसको चार्ज उस टाइम काफी टाइम लगेगा. दैट इज व्हाई अगर लास्ट टाइम के अगर तुम्हें सीक्वेंस ऑफ इवेंट्स अगर तुम्हें याद हो, तो आफ्टर टच डाउन उसके 4-4.5 घंटे बाद रोवर का डिप्लॉयमेंट होना था. सो दैट इज द टाइम, हाँ, कि between that they can do all the system diagnostic check and to get the rover fully charged. So that's why it takes so long, because जब तक वो इनिशियली उसकी शैडो से बाहर निकल के वो नहीं होगा तब तक वो बहुत स्लो चार्ज होगा, क्योंकि हाफ ऑफ दैट सोलर पैनल इज गेटिंग ऑब्स्ट्रक्टेड बाय द शैडो.
ओह इंटरेस्टिंग, ये नहीं एक्सपेक्ट बता था. आई होप इस बार हमें वो ब्रीफ मिले, एग्जैक्ट टाइमलाइन ऑफ इवेंट्स.
लास्ट टाइम मुझे याद है वो जो डिफेंस के जर्नलिस्ट हैं, आई एम फॉरगेटिंग हिज नेम, आई थिंक यू हैव बीन ऑन वन ऑफ हिज स्ट्रीम्स.
ये समझा मैं, वो उन तेजस, अरे
हाँ, तो वो उन्होंने ये शेयर किया था लास्ट टाइम. सो लेट्स सी. Yeah, he has not been active recently, the last few months, but yeah.
टारमेक आई थिंक ना, टारमेक कुछ तो उनका यूट्यूब चैनल, टारमेक 007. हाँ यस यस यस,
राइट. सो या
या
एंड
आपको कुछ एंडिंग थॉट्स? आई थिंक ऑल ऑफ यू नो हिम, बट वी स्टिल हैव 2000 people for some reason. To those 2000 people, if you all don't know him,
I think a lot of the people who have are done with the ISRO stream, they have now just gotten free and have joined your stream.
I think yeah, they might be behind or something, possibly. They might not be with us, maybe. But I think you're well known Astro_Neil on Twitter for food for thoughts and lot of information. Neil Bhaiya, thank you. After all these years it happened.
I'm glad कि it happened like whenever it has to, but yeah, I was looking forward to this day as well. And yeah, like I didn't get to say any final words to Rohan and Narayan, but yeah.
मुझे भी पता नहीं था इतने जल्दी जाएंगे करके, but I think Rohan got pinged by news and he had a meeting.
Yeah, I think Pawan was also gonna join you.
हाँ, वो अभी उसमें है, फ्रेंच परेड.
हाँ, आज ही मैंने उसका ट्वीट देखा कि वो बैस्टिल्स डे.
यस, आई एम श्योर ही मस्ट बी साइड में ही वो लाइव स्ट्रीम चालू किया करके रखा होगा चंद्रयान 2 का वहां पे भी.
अभी मैंने जस्ट देखा.
हाँ वही. थैंक यू भैया.
Thank you so much for organizing this stream, and thank you everyone for tuning in. It was really nice of you all, and like this was one of the best ways we could have celebrated the launch of Chandrayaan 3. And hope we'll stay connected, all of us, over social media, over Twitter, and on YouTube through YouTube. Garib Scientist, more videos that I'm sure he's planning.
Yeah, or dump a shit ton of them.
Yeah.
Yes.
So yeah, thank you, and I guess we'll see you guys over on other platforms.
Yeah.
I think.
And I'll just, before ending, thank you to all those who, I think some super chats came. I had specifically asked people not to do that because I wanted to spend time with the guests. Thank you to all those. There are too many new members and all. I can't humanly say all of them. Thank you, everyone. ज्ञान की गरीबी सबसे बड़ी। एंड अगर आप मेंबर हो तो आपका अभी नाम आएगा स्ट्रीम पे। ओह, थैंक यू टू ऑल मॉड्स स्पेसिफिकली, बिकॉज अभी मैं देख रहा था लास्ट मिनट बहुत गंदा हुआ चैट, तो मैंने उसके लिए वो मेंबर्स ओनली कर दिया था। तो अटनु भाई, एस्ट्रो भाई, 42 भाई, थैंक यू। आई थिंक जादू भाई भी थे, एंड वुटलाई चेतन, आई एम नॉट श्योर। थैंक यू।